So chapter number 6 after DFD, data flow diagram. Uh, we learned chapter number 5 is about DFD. How many types of data flow diagrams? 0 level, 1 level, 2 level. So now we are going to proceed further. Okay. So what we are going to cover in this analysis part, explain the rules and style guidelines for creating entity relationship diagram. So I hope you have done 400, you have done this course, database management 373. Have you done it? 373. I think most of you have done, and some of you have done with me also. So basically, this chapter is about that only, So creating entity relationship diagram, ERD, describing use of data dictionary and metadata, explain how to balance ERD and data flow diagram, and describe the process of normalization. So basically, we learn entire things in a couple of chapters in that C373. This we are going to just, since you have already learned, we are just going to brush up this knowledge. Why data modeling, defining the meaning of ERD, ERD creation, mapping ERD to relationship schema, normalization of relational tables. So now look into what is the data model. These are the key definitions. It is a way to represent data. It's a formal way to represent the data and used to create, and that are used and created by business systems. So basically, formal way of representing data, and that is created by a business system. It shows the people, place, and things, means people, place, process, things about which data is captured and the relationship among them. So basically, from where the data is getting, how the relationship among different datas are there, customer data, sales data, student data. For example, student data, your academic performance data, means different courses, your performance, your registration data, your financial data, which means course fee and other, your graduation related, your different aspect related data. So logical and physical view. Logical data model shows the organization of the data without indicating how it is stored, created, and manipulated. So this is the one. How it is stored, created, or manipulated. So it shows the model, data model. A physical model shows how the data will actually be stored in database or files. So these are the logical and physical view. ER diagram. It was developed by Peter Chen and published in 1976 paper, and popular way to depict the data model. Normalization is the process that analysts use to validate the data model. So basically, normalization that you have learned in 373, we are going to apply here. Data models should balance the process models. So after the data model, we will be going through this regarding their related data components and elements. Why data modeling crucial or important? Because data is a resource to be shared by as many processes as possible. Data organization must be flexible and adaptable to unanticipated business requirements, and that is the purpose of data modeling. And you must be knowing why data modeling is crucial, because data nowadays, you are competing, or businesses are competing based on data. So data is Even elections are competed, elections or whatever you can say based on data. Companies are marketing, businesses are marketing their product and services. Uh, Politicians are fighting their elections. So data is, crucial everywhere. Therefore, this becomes data modeling is very important. If you have right modeling, you can do the wonders. These are the steps in order to perform data modeling. Requirements, ER diagram, relationship schema, and relationship database. So this is what we are going to. So ER diagram, you can see this. This is that kind of thing. Company, product, process, product, relationship schema, you can see here, and relationship database, you can see here. Other data modeling issues, data structure and properties are reasonable, permanent, more stable than processes that use the data. Typically very similar to the existing system, data models are much smaller than process models and are constructed more rapidly. Constructing the data model helps analysts and users quickly reach consensus on business terminology and rules. So now this is just basic information and definition and meaning of ER diagram. Entity relationship diagram or ERD. This is a modeling technique, database modeling technique, and it provides graphical representation of data requirements that you have seen in the last 373. I believe that every one of you have already completed 373. Therefore, you are in this course. ER diagram, the result of ER modeling serves as a blueprint of the database. So these are the entity, these are the three elements: entities, attributes, and relationship. So entities are constructed that represent what the database keeps track of. The basic building blocks of ERD represent various real-world notions such as people, place, objects, event, item, and other concepts. So please look into this. The basic building blocks are, remember, these things, because entities, how you will represent, this is basic building blocks where you can have people, place, object, events, items, and other concepts. Within one ERD, each entity must have different name. Means each entity, for example, if people, the name should be different, or it should not be the same name. So please think what can be the entity. Entity can be people, place, object, event, item, and other concept. Entity members, so occurrence of an entity instances or members. So entities themselves are depicted into ER diagram, while entity instances are not. Entity instances are eventually recorded in database that is created based on ER diagram. No need to capture entities having just a single instance. So look into that. These are the properties we have to remember while doing so. Attribute, depicting the characteristics of entity. So entity has different characteristics. So represent the details that will be recorded for each entity instance. Within one entity, each attribute must have different name. So look into, these are other characteristics of attribute. Represent the detail that will be recorded for each entity instances. Within one entity, each attribute must have different name. Unique attribute, whose value is different from each entity instance. Every regular entity must have at least one unique attribute. So remember that, every entity will have some attributes, but one is unique. Relationship is the third part of ER diagram. Entity, attributes, and relationship. So relationship is the third one. So ER modeling construct depicting how entities are related. One entity is related to another, how they are related. That is called relationship. And within ER diagram, each entity must be related to at least one other entity by a relationship. Look into this. So this is, for example, this is entity. This is attributes. This is relationship. So basically, IDF1X, this is, this is a chain modeling, chain represented this way. Crow's foot, they represent this way. So, it's a three-way of representation. So for example, this is entity name, entity name, entity name. You can name here, you can name in this way, you can name, they are all same. So an attribute can be inside. So you can, inside the box, you can put the name of attribute. You can have these kind of, ellipse kind of attribute name. You can have, in this way. So these are the three ways of representing entity, attribute, and relationship. And here some people, they just on the line, they write the relationship name, IDF EF1X. Chain, he gives, relationship with this, square in this relationship name, and this is relationship name. So attributes can be, many. For one entity, there can be many attributes, but one attribute is unique for each entity. A relationship shows the association between two entities, has a parent entity and child entity. It described with verb phrase. Remember these, properties. Has one-to-one, one-to-many, many-to-many. Has modality null, not null, and dependent on or independent. So these are the three important elements of ERD. Please, focus on, please keep in mind while making drawing ER diagram, just, have these things clear. So here relationship is max cardinality wise. So basically, one-to-one. So one-to-one. For example, university and president. These are two entities. University is one entity. President in one entity. They have one-to-one relationship. One university, one president. One-to-many department. There is a one department, but 20 professors are there in the department. Like we have information system, business analytics department. 5-6 professors are there. Many to many, there are many courses, there are many students. So these are the three types of one-to-one, one-to-many, and many-to-many. So a maximal number of instance, one entity that may be associated with another entity. So A and B. One-to-one, one-to-many, and many-to-many. Relationship cardinality constant depict how many instances of one entity A and can have relationship with each of the other entity B. Entity A, entity B, this is the relationship. How many A instances have their relationship with each B instances? Max min. B instances have relationship with each A's instances, max min. And we are going to look into that. So here you can see these two vertical lines, blue and red. So how many instances have the relationship with each B's instances, max min, and how many B instances with max min? So look into that. Max, one or many. Min, zero, optional, or one mandatory. So this is the way, this is the representation of blue and a red line. And we will understand more with some. So max, one or many. So look into this. How many instances of one entity that can have the relationship with each of other entity? Maximum cardinality, one, represent a straightforward one. Many, that represent by cross foot symbol greater than one. So you can see if many are there, you can represent more than one. Optional, one is, so look into the blue, red is max and blue is min. So first one which is close to the entity, that is max one, and the other one is min one. So here red one is max one and then blue one is min one. Optional represent by circular symbol 0, or mandatory represent by straight war, or it could be 1 or greater than 1. So this is another, none or many LCA instances have the relationship with each chemical instances. For example, LCA is the, LCA is the, company, chemical. So look into the, we did LCA example in previous chapters, making, use cases and other things. So none or many chemicals instances have the relationship with each LCA instance. So look into this, 0, many, here red, you can see red is and 0 and 0. Each chemical instances are 0 means, this blue line. Each chemical instances has the relationship with none or many LCA instances. Each LCA, look into max is 1 or many, min is optional or mandatory. So here, this is the description which is given. Customer and sale, buy via. So this is buy, customer and sale, that is, max is 1 or many, min is optional or mandatory. So here you can see optional and mandatory. Exactly one customer instance has the relation with the each sale instances. None of many sale instances have the relationship with each customer instances. So this chapter more is about, practicing, because once you understand the chapter number 5, this is 6, it would be easy. So a lot of examples, a lot of, those are given there. You can see relationship may also have attributes. So for example, request LCA request the chemicals, chemicals request the LC, chemical, here many or 1. So here request has a quantity, how much quantity do we need? So relationship also has the attributes. So basically 3 things: entity, attributes, and relationship. Relationship 0 to 0, 1 to 1, 1 to many, many to many, and relationship also has attributes. ER creation, ERD creation, identify entities, add attribute, identify relationship. Balancing ERD with DFDs. So data flow diagram, external entities, data is stored corresponded to ER entities. So once you make the data flow diagram, you can start making ER diagram. Information pieces in data flows in DFD may become entity attributes in ERD. So look into the tune source system, and this is a zero level EFD. DFD zero level, which is customer, search, browse tunes, and shopping cart, purchase tunes, sales, so 1, 2, purchase tunes, 3, which is promote tunes. So look into all these, and some recognized entities, you can clearly see customer is one entity. Targeted promotion, customer favorites, customer interest, available tunes, sales. These are some of the entities. So available tune, customer favor, customer interest, target promotion, sale, customer, these can be. So identified relationship, customer, buy via sale, buy via sold via available tunes. So this is one identify relation. Customer is one entity, sale is one entity, availability is another entity, buy one, buy via is relationship, sold via is relationship. Now going more into the customer, buy via sale, sale, available tune, then it goes to contains, targeted promotion, and then it is going to be targeted at customers. So basically this is the ER, ER simple entity relationship. Now we have to add, attributes to look into, this is further going into this. Available tune is about customer favorite, has favorite, then it goes to customer, and customer favorite here attribute is favorite date edit. Now further, so look into mapping the relationship A1, A2, here you can see entity A has 2 and relationship here has 1 to many. So A1 has 2 relationship, A2 has 1 relationship. So this is entity A has, entity A is 1, entity 1 to. So here you can see it has A1 has V1, V2 relationship similarly. So here you can see this relationship is mapping. Now here you can see the foreign key, which should be, X1 should be here. So here, in foreign key, if you have done the MIS, the management information systems course, and we learned in that, what is foreign key, what is primary key. So here you can see E1 entity B, X1 is common, X1 is common here, foreign keys, X1. Mapping the relationship scheme, again, this is keep going here. So basically relationship, you have to understand how many relationship, 1 to 1, 0 to 1. So basically this is a sale, customer, available tune, targeted promotion, and customer favorite. These are the attributes in this. In customer, customer name, customer last name, customer first name, customer address, customer cities here, state, zip code, phone, email, username, password, all the attributes are there related to customer. So or similarly sale, similarly different entities, they have the attributes here. So what are the common thing in this? Here sale, customer username, tune ID, these are the two things. Here customer number, tune ID, favorite. Here tune ID, date created, customer number, and here, so these are the, now we come to, so these are the attributes that can be created. These are the unique attributes. These are the common attributes in in multiple entities, which you can create the relationship. Normalization. So these are the problems with non-normalized tables. Look into the name, start date, duration of the campaign 220T repeat 3 times. Here you can see in this, the name of the campaign manager repeated 3 times here. The media and range values for campaign mode 1 represent repeated twice. So basically, in order to avoid duplication, and it will come again and again, it will create a problem in order to understand, in order to come with the proper results. So therefore normalization is very important. So here you can see, if you can see this table, 3 times, 3 times, 3 times, or 2 times, this is coming in normalized table. Deletion and anomaly example, cannot delete campaign 44 without also deleting all the data about campaign manager CM13 and campaign mode 6. Modification anomaly example is here. Look into this. The change to change the duration of campaign 222 from 30 to 40 days, 3 records have to be modified. And insert an anomaly example, cannot insert new campaign mode without inserting an actual campaign using a new mode. So basically, there are checks, there are things that we have to do. So basically, this is the another problem with a non-normalized table, and then therefore normalization is important. Every relational table doesn't contain partial functional dependency to NF. 3NF does not contain partial or transitive functional dependency. So look into this, component, primary key, full dependency 3NF, partial dependency is 1NF, transitive dependency is 2NF, B2C, D2E, and full dependency 3NF. So 1NF, this is, so this is normalization is one of the difficult, it has entire couple of chapters in the book that we covered in 373. However, here we are just going to focus on overall things that we covered in entire course in this. So it is very important for all of you to go through the entire chapter and entire practice in those are given in the chapter. What is important from my side? 3 things: entity, attributes, and relationship. If you understand, we are not going to focus much on normalization, because so understand 3 things: what is entity, what is relationship, and what is attributes. What is the unique attributes in each entity, and one-to-one, one-to-many, and many-to-many many to many relationship, and relationship also has attributes. So these are the few things, and rest other theories are there that you can understand and as you go. Here I have few things which I would like to share before I so here I have quiz available for you, uh, and as you know there are 20 questions. I have not asked many. You have 7 days to finish this quiz, and this quiz has 2 attempts, and the latest attempts or last attempts will be graded. So you just do yourself. You can think, you can try once, you can try second times, and then also in the announcement I shared a study guide for exam 1, and these are the 3 important things that will be there. Feasibility analysis that we have done in chapter 1, use cases that we have done in last classes, DFD we have done in last class. So these 3 things are there. These are important, and questions will be based on that. You will have 24 hours time to do this. So which is pre-announced October 29th. From you will be having this test or exam available this. So if you have any question related to this, please ask me. I will be also available on Thursday in case if you have any issue. Like Ethan comes every day, every Thursday. If he has any question or anything,